All right, in this video we are going to talk about right triangle trigonometry. All right, so at this point we've already talked about the unit circle, and we've defined the 6 trigonometric functions in terms of the unit circle. So what we're going to do now is to look at how you can do this with just using a triangle and how it relates to the definitions that we talked about previously on the unit circle. All right, so first off, before we get started, here in this lesson, we're talking about right triangles, and that's a triangle that contains a right angle. So if a triangle is a right triangle, right, it has exactly one right angle because the angles have to add up to be 180, and so therefore you can't have two angles that add up to 180. That wouldn't leave any 180 degrees. That wouldn't leave anything for the third angle, right? So that means in a right triangle you have one right angle, and then the other two triangles are acute angles, less than 90 degrees. Okay. So in a right triangle, as pictured down here, you've got one side, right, that's opposite that right angle, and that's called the hypotenuse. So here C is the hypotenuse here. That is always going to be the side that's opposite the right angle. And then the other two sides are called legs of the right triangle. All right, so if you pick one of the angles, the acute angles in the right triangle, okay, so here I've picked this angle down here that's labeled T, okay, then the legs, one of the legs, right, is going to form the angle itself, okay. So here you can see this leg of the right triangle forms the angle T. And then the other leg is not going to be a part of the angle, right? And so we are going to call the leg that forms the angle, part of the angle, the adjacent side for that angle, okay? So for this angle T, this would be the adjacent side, okay? That is going to be the leg that forms the angle, that's touching the angle, right, is another way to think about it. And then we're going to call the other leg, the one that doesn't form the angle. So for T, this angle T right here, you can see that this leg does not form the angle. It's not one of the two half lines or two rays that form the angle. That one is we're going to call the opposite side. Okay, so for this angle T, the hypotenuse is always going to be, right, the side opposite the right angle. And then of the legs, right, the one that is part of the angle is going to be called the adjacent side, and the leg that's not is going to be called the opposite side. And now, which one is the adjacent and opposite is always going to be different for the other angle. So if I pick this angle up here, right, for this angle, this side over here would actually be the adjacent, and this one would be the opposite. So it's going to be different for different angles, okay? But it's real easy to figure these things out. And this is how we're going to talk about these trigonometric ratios. We're going to talk about those in terms of hypotenuse, opposite, and adjacent. So just remember, right, hypotenuse is always the side that's opposite of the right angle. And then for one of the acute angles, right, the leg that's touching it is the adjacent. The leg that's not is touching the angle is called the opposite side for that angle, and it's different for the other angle. It's reversed. Okay, so given that, right, we can start talking about some of these trigonometric functions for the angle T, for an angle in a triangle. Okay. And so here you can see that there's 6 that we talked about before: cosine, sine, tangent, secant, cosecant, cotangent. These are all spelled out. And what you would do, for instance, to find the cosine of the angle T in the previous image, in the previous figure, or the figure on the previous slide, is you would find the length of the adjacent side and then divide by the length of the hypotenuse. Okay, and then for the sine, it would be the opposite over the hypotenuse. For tangent, it would be opposite over adjacent. Secant would be hypotenuse over adjacent. And cosecant would be hypotenuse over opposite. Cotangent would be adjacent over opposite. Okay. So just to kind of connect that up to the definitions that we talked about in terms of the unit circle, right? In the unit circle, what we did was we had, oops, I'm trying to get that in the middle. With the unit circle, we had the coordinate axes that look like this. And we had an angle, let's say, that looked like this in standard position. And it looked like that. So we had an angle that looked like that. And then we had the unit circle. And wherever that terminal side of the angle cut through the unit circle, right, that point, let's call it x and y, right? We define the 6 trigonometric functions in terms of those two coordinates, right? And so the way this relates to the triangle is you can imagine that you make a little triangle that looks like this, a right triangle like so, right? By dropping a perpendicular down onto the x-axis here. Okay, and then if you're looking at this angle here, T, right, in terms of the unit circle, right, what we would say is that the cosine of T would be equal to x. Okay, which was the first coordinate right here. But you can see that if I look at this triangle that's formed by dropping this perpendicular down, right, what ends up happening is that this distance of this side of the triangle is actually x. And this side of the triangle, this side right here, is y. Okay. And then the length of the hypotenuse is 1 here. Okay, so if you go by the triangle definitions, right, the cosine of t would be the adjacent side over the hypotenuse, right? And so the adjacent side, right, would be the leg that's touching the angle t, which is this distance from here to here. Okay, and so if we go by that definition, it would be adjacent, which is x, over hypotenuse, which is 1. Okay. And you can see that comes out to be exactly the same. And if I check that for these 6 other, or the 5 other definitions, it's going to be come out to be the same number that we're getting, right, for all the trig functions, whether we use this triangle or whether we use this unit circle definition. Okay. And now you might say, well, okay, it works for that one little particular triangle, but what if I had, say, a larger triangle? What if I did this, right, and had a bigger triangle that looks like this? How would I know that I would get the same values using a bigger triangle? Because that point's, not even on the unit circle. What's the case in that situation? But if you think back to a little geometry, right, these two triangles, this little triangle and this bigger triangle, would be similar triangles, right? And so remember, similar triangles, right, the ratio of the corresponding sides are going to be the same. So even if you use a bigger triangle, it's going to come out to be the same as for this triangle here that we made by using the unit circle. So we will get the same values whether we use the unit circle or we use a triangle. The one thing about the unit circle definition, though, it's more general than the triangle definition, right? With the unit circle, I could have an angle that's over here that's bigger, or even down here, right, that's bigger than 180 degrees, whereas in a triangle, right, that's not going to happen. So the unit circle is actually a more general definition than the triangle definition. Okay. But in the case of these triangles, it comes out to be exactly the same numbers that you would get for these angles for the unit circle. All right, so here are the trigonometric ratios, right, in terms of the parts or the side lengths of the triangle. A good way to remember this is with the mnemonic device SOHCAHTOA, right? That stands for sine opposite hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay. All right, and so that is the general idea of how to define the trigonometric ratios in terms of a triangle instead of the unit circle. In the next video, we are going to work through an example of finding those 6 trigonometric functions using the triangle.